Hey guys, welcome back. Today in this video, in data structures series with Swift, we gonna work on trie. So we try to understand what is trie and what is useful for, and also we gonna implement it with Swift. So to start, I'll go to my document. So here you will see one trie, and let's find out what is trie. So trie technically is a tree-based data structure, and it has its own rules that make it to be good for keeping words and kind of dictionary. And what is this? Also, we know trie as a prefix tree, and the structure of trie is from one empty root, and which is nil, and then we, as far as we come down from this tree, we will start with the first letter of our word, then second letter gonna be in child of that trie, and go on. So I'll go over that later. Just briefly, I want to tell you about the trie, and about the terminology of a trie is same as a tree. So we have root, we have we have root, which is the first node, which have edge, which is the connection between two nodes. We have key, which is the address of the node and technically value of the node, and also we have child, which is the this is child of root, and this is child of this node, so like that. And we have parent, which is the actually for example, the root is parent of this node and this node, and this node is parent of this node. So and also we have leaf and path. As we know, we have parent, sorry, we have subtree, which is a group of trees. We have siblings, we have leaf nodes, which is the last one also. And high, for example, of a node is length of the longest downward path to leaf. And so for example, root is maximum high have, or this one has high 1, and depth is path from node to root. So leaf has a maximum root depth, and root depth is 0, and of course high of leaf is 0 as well, and so on, which are a lot, and we will review all of them in our tree video. So I just say about the internal and external, that this guy is internal because have a children, and this guy is external because does not have any children. Okay, so let's go through one trie and look at it and try to learn it. So here you go. We have a trie. This trie root, as you see, is nil, and then as soon as we start with one letter, which is the first letter of our word, and then we have second one. If you have extra, it's gonna be third one, and you will see how it's gonna be like this. So key is T right now, then this key is TE, and for this T key is TEA, and you will see that's how it works, and very organized. You will have all of your words in one trie. Okay, and just some operation remain. That's on try on your implementation, you can add some. You need to have some operations and methods. Insert, for sure you need. You can name it append or add. Search, of course you need. You can name it find, and this will tell you that one word exists in your trie or not. Remove gonna remove that one for you, and is final just tell you that your node is the last node, is a leaf, and contain just tell you that your trie or your node containing that word that you are looking for. And there could be more in our implementation, you will see. Okay, so let's jump to coding. So I'll go to my LeetCode playground, and here I start with the Swift. I name this LeetCode playground generic try, and here I start with hello world. So as you see, so I just say hello try or hello generic try, because I want to make it generic, but you need to know that technically try is a string for a string, so there's no point if we do it fully generic. But if you do it then later for other problems like Morse, you can use this as well. Okay, so let's start. So first of all, I'm gonna create one try node. So here I just say a node in the try, and I just say class try node, type of T. My keyboard disconnected. Okay, again connected. My and T type, and I make it hashable. The reason I make it hashable because I need to be able to compare it. Also create a hash from that. And so as soon as inside what I need a value. Here word setting our word, but for now it's generic, so type T. I make it optional because it could have no value, nil value. And I make one week variable by the name of parent node, and type of try node. This is optional as well. Also, you may ask why it is weak, because we need to be careful of memory leak. If I don't make this weak, it's gonna be pointing to child, and child gonna pointing to this. So this we will create a circle, which is name of it is retain circle, gonna take your memory more and more and more until your software, your app gonna crash and jump out from running. And if you want to know why it's happened, you can watch my video for memory leak or automatic reference counting, which is one counter by compiler that counting your not strong or weak variables, and when you gonna they get nil, then gonna remove them from memory. But it's not our subject right now. I don't want to make you confused. I just told you about that very briefly. Okay, so let's go to and continue our code. So yes, and after that we can declare our children. So variable children, and this variable is not it's kind of array type of T, and each one include one trie node. So array of trie nodes, and at the beginning it's gonna be empty. So key is t, and trie node is gonna be value. Okay, after this we gonna be create var is terminating, or it could be is final, whatever you like, but for now I put it terminating, and which is value is false at the beginning. And at the end we gonna we're gonna create another variable which is say is leaf. So if just return if this node is leaf or not. And I make it completed properties, so I just say return value of this gonna be return of children dot count equal 0. So how it's happened, because here you will see that I said okay, this is my children, and it's an array. If this array is empty, or its count of it is 0, then of course this guy is leaf. Yeah, and that's why I use completed property here. And so now I'm gonna create an initial constructor for that. In Java we say constructor, here we say initializer. So just add here only for this function I'm gonna add markdown inline commenting for Swift. I just want to give you an idea how you can make your program documented as way as you are writing your codes. Okay, so initialize a node here, and should be 3. Okay, 2 is enough, but 3 is when you want to make a declaration for your method or your class. You need to follow some rules. Then this will show up with Xcode when you just command click on your method and show you this declaration to give idea about others that they don't have idea that what this function is doing and what is it for. Then with documentation you can guide them. So parameters, so let's get one value. This is the value that goes into the node, and another parameter is parent node. This is a reference to this node's parents. Okay, again, so this you see that I add some comment here, but these comments, it's not only a comment here, but you know, later in Xcode, when I wants to add the initial, use this function, as soon as I write, command click on this, then I will see this explanation there about the parameter and what this function is doing. Later, if I find the room time, I'm gonna make a video for that. Mark down or mark the up commenting, which is a standard Swift documentation for now. Okay, so my value at the beginning gonna be type of T and the value nil, and parent node gonna be type of try node, optional, and it could be nil. Okay. Yeah. Okay, so I just say self dot value equal value, and self dot parent node equal parent node. Okay, another function that I need one add as well. Let me add markdown documentation for add as well. Then we don't do it for the rest to keep video shorter. And okay, so add a child node to self if the child is already present, and then if already present, what it's gonna do is gonna do nothing. So parameter, it's only one parameter, so let me do it in this way. Parameter value the item to be added to this node. Okay, so I'm gonna create my function add value type of T. So what is gonna do? Gonna say okay, guard. Why I use guard? Because children could have nil values, so I need to be able to deal with that. It's one of the ways to approach to optional variables. Equal nil else return. So this is that if there nothing, it's gonna do nothing. So this part of our code doing that, and then we say okay, our children value equal our try node of value and parent node of self. Here we go. So this gonna be end of our, not end of our implementation, end of our try node. But our try node is finished here. But now I need to create my try. So okay, this only was my node. So you will see here I'm using composite design pattern. Yeah, I invite you to watch design pattern series as well, just to learn about the design pattern. It's really useful for you to be a team worker. NS objects and NS coding. You know what? Let me say okay, so oh sorry, just a little bit made a mistake here. So here I was writing comment, I just missed it. So try is the data structure containing words. Each node is a single and character of word. Okay, so here I define my try. Okay, so I used the generic. So what I need to do now, I need to use type alias to say what is this generic. So try node of character. Okay, and I can here declare the number of words in the try. So public variable count from type of integer. This is a property, property, computed property, which is my word count. Also, here I can say is the try empty. So public variable is empty boolean this one return word count equal 0. So here we just say our count is our word count, and our public variable, public variable, yeah, this part my keyboard goes down, okay, is empty of type of boolean. Yeah. Okay, and let's see what else I need to define. Okay, so I believe now I need to define word. So public variable words, which is an array of a string, and this is computed property which return words in subtree root node. Again, so about words, let me just some decorations. So all in the try. Okay, but of course my nil, my root's gonna be nil. Also, it's 5 privates. And it's let, it's constant, it's not gonna change. So variable word count. You will see this is very important for me. Word count on type of integer. I don't give it value, but then in my initializer, I'm gonna give it value. So here I create an empty try. So here I just say override init for me by this. So root equal node and word count equal 0. Also my super init I'm gonna inherit from that. Okay, I believe yeah, I done just the main parts. No, you know, if you remember, I just declare my try to be NS object and NS coding conform these two. So for this two here, I need to just write mark NS coding. So here I'm gonna initialize the try with words and archive. Parameter decoder, which is decodes from an archive. This is the next feature. Maybe you don't want it, but it's good to know that you can do it. For archiving, you can use this. Okay, my coder, decoder, NS coder. So self init, let words equal decoder dot decode object, sorry, decoder dot decode object, yes, object for key words this guy as string. So I'm gonna iterate in there. So for word in words, which is not gonna be empty, self dot insert word word. Also we will have encoding. Encode, so this guy gonna encode the words in the try by putting them in an array, then encoding the array. function with code there from type of ns coder. So function encode, here gonna say coder dot encode self dot words for key words. Okay, I think we done our main part of our try, but for sure I'm pretty sure I'll have some there are gonna be several mistyping, so let's see. First one I think is, let's see, so children I think is one of my mistakes. Okay, so line 70 just said self init. Self.init, yes. Yes, I missed dots here. Okay, clear run. Okay, line 13. Yes, we made this children, so this should be children. Again, clear, run. And as coding, I believe as in my try declaration should be capital. I'm working with, if you work in Xcode, of course you don't have this, it's gonna pick up all of them visually for you, but we work with online coder just to give you idea, to learn about lead code and in interview situation. Okay, so like this, now run, clear and then run. Okay, ns objects, I believe O should be capital as well, yes. Okay, 73, line 73, here should be dots. Line 60. Okay, clear, run again. So line 69, NS coder, yes, S should be capital. Yeah, let's see, and NS coder line 81. And line 34. At the end, myself is not correct. Let me do this later. Line 53. Okay, let me run. .34. And it just said can children in a scope. Yeah, probably my children mistyping. Okay, value mistyping. Only. And this one 53. Okay, word in sub 3 mistyping. Words, yeah, words in sub, not 3. Try. And I believe this node line 60. Okay, let me clear this, run this. Gain words in sub, try. Oh yes, because I did not declare this. Yes, this part is it's for feature, and we will have this error until I declare this. And okay, for this one node missing arguments. How come I declared this type alias at desktop? And self insert. Yeah, we don't have this one as well. Yeah, I think this one we don't have it as well. I'm gonna deal with that later. Okay, so for now I save it, and then I need to continue to avoid some other of errors. Okay, I come here. I'm done here with my try, and here I'm gonna add an extension. We could write it down there, but I prefer to write an extension for my try. Here and okay, so here if you remember we got error for insert. I'm going to declare function insert. So I'm gonna guard opposite of word. If it was true, you know, if it was false actually. Is if the word was empty, it was not true, then it's gonna go to else, yes? And else gonna return. Okay, first of all in insert I'm doing that, then I'm gonna say okay, I create a variable by the name of current node, which is equal root, and then I just say for character in word dot lowercase. In this iterate if let child node was current node dot chill try. You know what? I add a lot of wrong children. I'm gonna fix them. Character. Let me finish this function, then I'll go fix all children's. Q so my current node equal not capital child node. Okay, else current node dot add value character. Then my current node equal my current node dot chill enforce it. Okay, so this was end of my loop, my iterates. Yeah, this one. End of if, and then here I'm gonna say guard. So word is already present if I get to this point. So I'm gonna guard current node that is terminating, otherwise return. So now I'm gonna say word count plus 1. So my current node dot is terminated terminating is true. Okay, so yeah, this was my insert function, but I want to fix my children's here, so let's go. Let's see where we have it. Okay, let me save this, clear, run. Yes, we need dots for inserts. Okay, for current verb, here I need Okay, word count plus equal 1. Okay, word in subtree, that's correct, node is correct, and yeah, so this one, we missed one L. So yeah, let's clear and run. Okay, so we have only these two. Yeah, okay, so we move forward. So let's see what else we can add. Yeah, so we add inserts. Now I want to add contains. Okay, so just say function contains word string okay, word string also match perfect prefix which gonna be boolean, but I give it default value false. So if I didn't use it, then it's gonna okay, so boolean returning. Okay, so how we do that? First of all, we check our word if is empty, otherwise return. So if when it's empty, we can return, and then we carry it. We create a variable character. No, it's not character. We create variable current node, which is root. Then we gonna for loop character in word dot lower case so in our word character by character in our then we will guard if any child node equal current node dot children characters, otherwise return false. Okay, so now I just say my current node equal child node. Okay, so we done our for loop. So here I just return my match prefix. So why I do this? Because as if already we say false, then we're not gonna return anything. We're gonna return false. Okay, current node dot is terminating. Okay, if it's the last node. Okay. So this for our contain. What else we need to add? Let's see what else. I believe yes. Okay, we need two more. Find. You can find one to find in last node of. Also find terminal node of. Yeah. Also for deleting. Okay. So I write another one. Some of these functions may be not required, but I write it down here for you to, in case of one problem that you're facing with, you can use this. Okay, function find last node of this word. Yes, from type of string. Then return node. It's going to be optional because it could be new. But yeah, okay. So variable current node gonna be root. Then for character in word dot lower case, then again guard let child node was current node dot children character, otherwise return nil. Then current node equal child node. So return current node. Okay, so another function I'm gonna declare is gonna be find terminal node. Okay, so function, let's make this private as well. Just internally we're gonna use it. Function find terminal node of this word. Yeah, so this gonna return node question mark, and if let last node was equal find, okay, look at this, we're gonna use that function to find last node of word, then return last node is terminating, otherwise the last node nil. So I'm gonna return, let me explain this. I'm looking at the last node and should be capital. Okay, I'm looking at the last node that here I just declared. If this was terminating, it was last node, then this is true, then I'm gonna return that one. Otherwise I'm gonna return nil. Okay, and if anyway I pass this, I'm gonna return nil again. Okay, so here we found the last node is terminating or not, and now I'm gonna another private function by the name of delete nodes for word ending with. Okay, so terminal node is this node. Okay, so what's gonna be this? Okay, I say var last node equal terminal node variable character equal last node dot that value. Yeah, character gonna be equal value of last node, and then here I just say okay, while last node is leave and let parent node is last node parent last node of parent node. So do the while like this, and then what I'm gonna do, I just say last node equal parent node. I make last node parent node, and then I just say last node dot children character shouldn't be new. I make this new. All of this I make this new. Then I just say character equal last node dot value. Okay, if last node dot is terminating, then brackets. Okay, so this gonna delete all nodes for word ending with this terminating. Okay, and so now it's time to write remove. So now writing remove is going to be much easier. So here I just say function remove word from type of string. Okay, first of all I guard if my word is not empty. If it's empty, I'm gonna return. And again I guard if I can terminate nodes, get terminate or terminal node, yeah, terminal node equal find terminal. Find terminal node of a word of word. If not, what I'm gonna do, I'm gonna return. And okay, so I just say if my terminal node is leaf, then I'm gonna say now I'm gonna use that for another private function, delete node for word ending with here terminal node is terminal nodes. Okay, so if this, otherwise else, terminal node is terminating equal false. And don't forget, word count -1. Okay, so now we remove this word as well. Okay, so let's see what else we need to do. Okay, I think we only have two more functions to do, which are words in subtree and words with prefix. I'm gonna use them. Actually, the first one is using by the second one. So the first one gonna be file private. Okay, so the first one gonna be file private and function words in sub try. Okay, so root node from type of node and partial word from type of string. These guys return an array of string. Yeah, so it's gonna return array of string, and okay, here I just say var sub try word equal array of string, run it. So it's gonna be empty array of string, and here say I var previous letter equal partial word. We will get it from our here argument here. Okay, and here I just said if let value, I could get value of root node dot value, then previous letter. You know what, let me put one S here, letters. It's gonna be not one letter. Okay, letters dot append value. So I make my array. These are my array. Okay, if root node is terminating my sub try words, I'm gonna append to it my previous letters. Also, I'm gonna for loop in child node, actually in root node dot children dot values, and I just say let child words equal words in subtry root node child node, and partial word gonna be previous letters. Then I'm gonna say my sub tries fourth. I'm gonna add to it my child words. Okay, then I'm gonna return my sub tries words. Okay, so yes, something missing here. Yes, so here I need one curly for this guy. Okay. Okay, so my main function for find words with prefix gonna be this. So prefix parameter type of a string. This gonna return for me an array of a string. Okay, so our variable gonna be words actually. It's gonna be, we're gonna return this at the end. So array of strings. So I just select prefix lowercase equal prefix dot lowercase Okay, so I'm gonna lowercase it and keep it as this because I'm gonna work with it after this. So if I was able to get last node by this function, find just top private function that I create, find last node of, so where my word is prefix lowercase. If I was able to do that, then what I'm gonna do, I'm gonna say if my last node is my terminating node, then I'm gonna add these two words. So I'm gonna append prefix lowercase to it. Then after, I'm gonna add the rest. So child node in last node dot children values. Let child words equal words in some try root node child node partial word my prefix lowercase. Okay, so now I just need to return my words. Okay, I think we're done. I'm done. And let's see, yes, it seems we are good. So now we need to get errors, so run. So this one, okay, here in line 113 we have one return. Probably I missed something. In contains, yes, I should return false. Save, run, clear, run. So line 60, leave it alone. Now line 128. Guard. So current, I believe one are missing. Okay, let's see if I can fix something else, some extra. 164. Delete nodes for word ending. Okay, so delete node for ending. Probably I mistyped this, so Okay, save, clear, run. Find last node of line 137. This is not defined, so find 150. Is terminating. Is terminating. 173. Partial word. Hundred 75. Previous. $78. Trie. Words. Okay, trie words here. Trie words. Okay, so clear, say run. Okay, 182, and so this is tries. Oh. Yes, and okay, so let's clear run. Okay, 148. Here, alright, yeah, probably this one. Save one. Oops, clear. Okay, run. 48 children. This is extra. Oh, okay, so we have only this one. So let's go line 60 and look at this. So line 60 here it says missing argument. Okay, so what is this? So node here, I got this a type alias from Trie node of character. So let's go and definition, look at the definition in this for init of this. So we don't have init of this. Yeah, we have this init, so which is this nil. Okay, so you know what, I need to give nil value to this one in case of nothing in between parentheses. Yes, so I believe now we will be fine. Yes, here we go. So now we have our implementation without errors. So what I'm gonna do now, I'm gonna jump to create my try and do it. So let's go. So now here we say variable my try equal try. Perfect. Then I'm gonna say my try dot append word, for example, Rolius. Okay, so I'm gonna make several copy of this. And I'm gonna give them values. So this one Rolius, okay, so for example I make this Rolades, I make this roll, and I make this round dim, round this. You know, I just try to make some sub-tree for each other, and yes, so round ding, for example. Okay, and here I just say round. And I add, for example, boost. And BOO. Okay, so now after I did all of this, I'm gonna print my try. So my T should T gonna be capital, yeah. My try dot find round. Also I print my try dot find of roundy, or print my try dot find RO. Yeah, I forgot to put this between quotation. Yeah, and print my try dot find B. Okay, so now I'm gonna run it. Oh, sorry, I made a bad mistake. I used append, but it was not append command you know, yeah, it was my command was add, actually, not sorry, insert. So insert also for find what I have, let's see. Yeah, I think we need to find word with prefix. I need to use this. Then here I need to use you know what, yeah, I'm gonna use this. You know, this is broadcast. For sure, you know that then I don't have to write this. Okay, so save and clear and run. Here you go. But it's not working fine. I just got round, and which is not correct. So for round, I should get much more. And okay, so let's go and check it out. Okay, so if we go, I think we need to go, yeah, to this function, and just we're gonna start from this function. So here we're gonna get prefix, pass it, and we have a start with words, and so prefix to make it lowercase, and then we look at find the last word of last node of that this word, and if it was and, then we're gonna add it, and then we're gonna go for this for loop, so to add the rest. So this is the problem we don't have the rest. So here last node, children values, yeah, correct. So here we find it. Oh, here you go. Here I need to, after this, I need to add it to words. I missed that. Plus equal child words. Yeah, I believe we are fine. It should be fine for this point. Yes, here we go. So now let me save this, clear this. We go up and look at this again, run it, and just talk about it. So here you go. You will see for round. If I double click, you will see I should get this 4. So yes, I get it. If I go for round D, I should get this 3, yes. And for RO, I should get all of this, yes. And for B, I should get this too, yes. Now this is perfectly working fine, and we should be fine. I just go through, not here, excuse me, I just go through here at the beginning of this. I have some problem from lead code that says the first one is the best solution is going to be this, so auto completion, because you just search for word in, you make everything in, put everything in try, and then just look at it. Just look at perfects when they type. You can just give them an array. Yes, we're gonna, in one video we're gonna review this because in this I believe they ask for how many times it's searched for. Then you need to add some variable to your try definition. Yeah, that's it for today. I hope you like this video. If you like it, please make sure to give this thumbs up, and also don't forget to be subscribed to have access to all videos that I make for Swift. Have a good one. Bye bye.